welcome back to the class. So, in the previous class I talked about the concept of chemical computer. Chemical computer. Okay, it will be a very small device, it will be quite cheap. So, to make chemical computers, what do we need? We need something called logic gates. Logic gates, and then we need, for the infrastructure, we need molecular wires. Amongst other things. Of course, we need molecular switch, molecular rectifiers or molecular diodes. Some of them have been realized. Molecular rectifiers. Okay, so, all these things together is called the subject of molecular electronics. So, this is a use of supramolecular chemistry in material science. So, we get molecular electronics. You know that all these things, logic gates, then logic switch, of course, all these things, wiring is our normal wiring, they used in silicon based computers nowadays, but if you make computer with molecules, then these things will be necessary. So, I will just touch upon this. So, I will touch upon give some examples of logic gates and molecular wires, and if time permits, then I will talk about molecular rectifier also. So, these things are all available in the literature in the form, and there is a book also on molecular electronics. A scientist by the name of Ratner, okay, a scientist by the name of Ratner, and another scientist in IBM, Avoris, they are into this chemical computers. So, let us first discuss what is logic gates. Here fluorescence is very important. Why? Because fluorescence is sensitive, fluorescence is quick, and fluorescence can be selective also. So, now let us see a molecular logic, and when I say logic gates, I have to talk about another thing, truth table. These are all there in the computers, Boolean algebra, truth table. So, I will be giving you that what are truth table for a particular logic gate and so on and so forth. So, first the simplest of logic gates is yes logic. Usually when you write, you have to write like an italic and all capital, yes logic. So, italic, this is my italic, but you know that you have to write italics. If you cannot write italics, at least write all capital. So, yes logic gate, this is the simplest of logic. here a low input gives a low output. Okay, low input means 0. So, truth table would be for yes. Say truth table side by side I am going to write truth table for yes logic gate. Okay. So, input is a single input, single output, input and output. Input and output, input is 0, so output is also 0. Okay. Input is 1, output is 1. So, it is a binary logic, like we have semiconductor based, all binary, here is also binary. So, this is the compound, this is a logic gate for yes logic. Same old anthracene. So, this is the compound. Okay. Now, when I excite it, what happens? Because of PET, when I excite this molecule, then because of PET, what will happen? No fluorescence, PET is on. Now, I put proton, simply acidify, I add proton, then what is going to happen? I am going to get a protonated form of this NH plus. So, N is plus now, positively charged. Therefore, when I excite it, there will be no, because it is a quaternary ammonium nitrogen. Okay. So, there is no lone pair. So, therefore, PET is blocked, completely blocked. So, when I excite it, I will see high fluorescence. So, here is the logic, input 0, output 0. Input 1, here input in the form of proton. So, when input is 1, output is 1, because I get very strong signal fluorescence. So, therefore, this is a yes logic. How about a not logic? Not logic, similarly, let me write not logic. I am writing just capital, okay, not. Okay. So, here is an example of a not logic, not nitrogen, okay, nitrogen, okay, 1, 2, 3, 4, 5, and then I get here benzene, carboxylate group. Okay. All right. So, what happens when I excite it, because this is minus, okay, because this is minus. So, what will happen? When I excite it, there is no input is nil. Oh, one more, that is what I am thinking. Okay. All right. There is no input, but when I excite it, then I see input, strong fluorescence, output. When input is 0, but I excite it, then I see out strong fluorescence, so 1. But when I protonate that, okay, when I protonate that, why it happens? It happens because of this excess. Upon excitation, this is my fluorophore. Upon excitation, this can go here. This can go here and PET will be on. Okay, PET. So, these are all PET based logic gates. So, no input, 0 input, excitation, strong fluorescence, okay, because PET will be blocked, okay. PET will be blocked, but if I put PET from there to there will be blocked, because it is minus, because this is negative. If this negative, it cannot get more electron, okay. So, it is not possible. But if I protonate that now, protonate that negative charge is gone, it is this. So, therefore, when I do this, all right, when I do this, what will happening? When I put 1, then this PET is possible. So, I will tell you again, when this was carboxylate, I took a carboxylate in the basic medium and input is no input. So, I excite, I get an output, but I put proton. So, carboxylate becomes carboxylic acid. So, now, carboxylate become carboxylic acid. So, therefore, PET is possible. Earlier PET was not possible. Why? Because O was O minus. So, it will not accept any electron, because it is already minus. It will not accept more minus. But now, when I add proton, then that minus is gone. So, therefore, now PET will be on. So, output is input is 1, means proton, output is 0 because of PET. Followed? So, you in your home, you make this and then try to think, when it was carboxylate, carboxylate was negative. So, no electron flow from here to here. So, PET was not possible. So, therefore, upon excitation, strong fluorescence. But when I get an input H plus, that is I make it acidic, then it become carboxylic acid, whole thing, and then negative is gone. So, now PET is possible. Because PET is possible, output is 0. It is exactly opposite to this. Previous cases, input was nothing, output was also 0. But when you put a proton, that PET is blocked, now output is also 1. Here is exactly opposite. So, this is a not logic gate. Let us go to another AND logic gate. AND logic gate is easy to understand. AND logic gate. Just by looking at this compound, you understand that this is our compound. We made it, AND logic gate. AND logic gate, there are many. Okay. AND logic gate. Okay. Very clever design, this AND logic gate. Okay. No. Then this is a simple type you already are familiar with by now, and then as a macrocycle. As a macrocycle, there will be two carbon. 1, 1, 2, 3, 4, 1, 2, 3, 4. Okay. So, it is small. So, therefore, look at this AND logic gate. AND logic gate means if I put a copper, suppose I put a copper here, I put a copper metal, copper. If I put copper here, then this lone pair is blocked copper. So, no PET is possible. Okay. So, no PET is possible from this side. However, PET is still possible from this side. There are two sides for PET. One is from here to here, the other is from here to here. Other is from here to here. So, now both must be blocked, only then we can get fluorescence, because if this is blocked, but this channel is still available, so I get no fluorescence. So, let us write, is a 2 input single output, input output. Okay. So, input output means input 1, input 2, input 1, input 2, input 2. Input 1 is 1, input 1 is 1, input 2 is 0, output is 0. Okay. Of course, this is also and input 1 is 0, input 1 is 0, input 2 is 1. If I put sodium, then this path will be blocked, but still this path is on. So, therefore, also output is 0. But if I put both copper and sodium, so that is AND logic, copper and sodium, then output is 1. Okay. So, this is the truth table for AND logic. And another AND logic, I will show you another AND logic. It need not be all chemicals. Suppose this compound. So, it will be very interesting if you can design your own compound. If you design your own compound, it will be really interesting. Out of that, AND logic is not a very difficult thing to have. Okay. So, this is my compound. Yeah. Now, if I add H plus AND, this is the significance of AND logic switch, and 365 nanometer light, we can get a laser light 365 nanometer. Then what happens? This compound will be formed. If I put only H, nothing happens. If I put only 365 nanometer, nothing happens. That means input 1 is 1, input 2 is 0, nothing happens. Input 1 is 0, input 2 is 1, nothing happens. But when input 1 is 1, that means input 1 is hydrogen H plus, and input 2 is 360 nanometer light. Then this compound transform to a new compound, and that is very strongly fluorescent. This compound is very strongly fluorescent. Okay. O plus, and then this is very strongly fluorescent. So, that is the significance of H plus and 360 nanometer light. Again, if I remove this 365 nanometer light, it will open up. It will open up to this, and this one is low fluorescence, this is very high fluorescence. So, this is also AND logic, both are AND logic. Okay. Now, NAND logic. NAND means you have AND, NAND logic. Let me draw in the next page. NAND logic. NAND logic means AND logic and gate with a NOT logic operation. So, these are standard logic gates we use to make computers now operation. They do it in circuits, and we are doing with chemicals, that is the difference. So, let me write the system, it is a complicated, I will write. So, AND gate with a NOT logic operation will give you NAND gate, NAND, NAND gate. Okay. This is, I am drawing that NAND gate now, 1, 2, 3, 4, 5, 2, 3, 4, 5. Okay. Now, lot of thinking went into making this particular compound. You will see O, then N, okay, N, Okay, I put this N, and then I have to put this N. Okay, then I put, it's quite complicated, very complicated to draw, quite difficult to draw. Okay. All right. So, this is it. Even this cyanide is very important. Okay. In this case, what happens? If I excite it, this is my fluorophore, nothing is there. If I excite it, then what will happen? If I excite it, okay, let us see NAND truth table, let me first write NAND truth table, 2 input, input 1 is kind of complicated, input 2 and output. Okay. NAND logic gate. Input 1 is 0, input 2 is 0 and output is 1. Input 1 is 0, input 2 is 1, then output is 1. Then input 1 is 1, input 2 is 0, then output is 1, and both input 1, input 2 also 1, output is 0. So, this is a very funny truth table, but that is what it is. Okay. Now, explain it. If you ask me to explain it, that is what is now a problem. Here you can put barium 2 plus, barium 2 plus. Barium, you know that barium in the periodic table is lower. So, it is a heavy alkaline earth metal ion, it is a big size and it does not fit here. So, it fits like you have this macrocycle and barium sits on top, little bit above that, okay, little bit above this macrocycle. And then what happens? If I put, I am just putting is, if I put SCN minus, okay, if I put SCN minus, then what will happen? There will be PET. Why? Because the SCN is minus, so it will come here. Why it comes here? Because this is a single bond. This is very interesting. This is a single bond, so it can rotate. It can rotate, and this part after rotation it will come close to this. From this picture is not very clear, but if it rotates, you can imagine the whole thing will come very close to here, and it will be PET will be possible. So, one is your input 1 is barium. When input 1 is barium, it is above here, but nothing happens, no PET, okay, because this and this are way apart. So, no PET, and above and not only that, barium is 2 plus. So, there is no PET possible. Therefore, input is 0, input is 1, okay, and input 2 is 0. Input 2 means thiocyanate, okay. Input 1 is barium, input 2 is thiocyanate. So, when input 1 is 1, and input 2 is 0, no thiocyanate, okay, then what will happen? There will be no PET. So, we see a strong fluorescence, this one ho gaya. Now, input 1 is 0. Input 1 is 0 means there is no barium. There is no barium, but there is only thiocyanate hanging here. Okay, barium thiocyanate, only thiocyanate. Only thiocyanate means it is a negative. So, when I excite it from this negative, it can be PET. So, input 1, so this one is no barium, only thiocyanate present, but this is a negative. So, there will be PET, okay. Alright, there will be no PET because it is hanging here and there, thiocyanate is hanging. Because no PET, so I see a very strong output, high fluorescence, and both are absent. Both barium and thiocyanate are absent in this molecule. If I excite it, no question of PET. So, both are 0, output is also 1. It is a very interesting compound. Now, when both are present, barium is present, thiocyanate is also present, then my output is 0, because now PET is possible. In other cases, only barium present and no thiocyanate is this one. So, my input, this is barium, this one is barium and this is thiocyanate. Okay, this is thiocyanate and this is barium, input 1. So, you look at this, when both are present, because of this is tilted and this comes very close to this moiety. And why it will go? Because of this cyanide. This cyanide attracts electron density towards itself. So, therefore, it has a very strong tendency to accept electron wherever it is available. So, here when it is coming here. So, minus, from minus it will be PET will be possible. So, when both are present, output is 0. So, this gives an idea about NAND. So, there are many other logic gate. Okay. We have realized, I did not bring it here, but we have realized like NOR, okay, our cryptand. If you recall our cryptand, which one? Which one? This one. This was our cryptand and fluorophore. Remember, I told you that it is a poor chemoselectivity. That means, if copper is input, then we see strong fluorescence. If nickel is input, we see strong fluorescence. So, look at my English, copper or nickel or manganese or cobalt or iron or. So, any of them input, it can give strong fluorescence. So, this is an example of an OR logic. OR logic. So, that means there are different types of logic gates has been realized. Okay. So, it is a we have a long way to go, because this once you get a logic gate, these are very fast, that is one good thing, and once we get a logic gate, logic output, then we have to integrate that through molecular wire with other systems to get this ultimately a circuit with only chemicals, circuit made up of chemicals. We know circuits are made up of wire, but here we are talking about circuits made up of chemicals. Why? Because this is a very small, so the problems of top down approach is not there. because we can really get a very small system in the nano world. So, we can get this wiring done, we can attach many other rectifier and all that. So, next time I will be talking about molecular wire. Thank you.